Alrighty, for the second to last time this summer, everyone, welcome back to the final week of our Summer Tech Bytes program here at the Schaumburg Library. Over the summer, starting on the first week of June, we have come a long way in terms of our programming skills, and not only this past couple months, but also throughout January. We started out with our spring programs, and over the summer, we made a bunch of progress throughout our three main programs, Web Development Bell Day, MIT App Inventor, and Web Product Development, where we have expanded and learned a new language of JavaScript, made some awesome projects, and continuing to finish those out tomorrow, while also looking at some new things like app inventing and the app development process and the cool things which we can do with this idea of computer science. As you guys can see towards the bottom right, it is the 8th week and the final week of all of our programs, and today is the last session of our MIT App Inventor, where we will be wrapping things up. So once again, as always, thank you guys for coming through. Good to see that we got people coming through as the conclusion of Tech Bytes comes about. Without any further ado, let's get towards what we're going to be accomplishing for today and finishing off MIT App Inventor with. By now, these slides should have been deleted a while ago, but you guys are well aware of who me and Lavdi are. We're also thank you guys going to be an incoming freshman in just 2 weeks, the first day of school at the University of Illinois at Chicago, majoring in computer science. Lavdi and me, it seems like yesterday, we're talking about we just graduated, had our pictures there, but now looking towards the next chapter.
Yep, and my name is Lavdi. In a second. All right, yeah. It is crazy how we were just talking about going to college in the fall, and the fall is here in about 2 weeks, in less than 2 weeks actually. Time has flown by, but we have learned a lot. We have had a lot of fun in Tech Bytes, and looking forward to the last 2 days of Tech Bytes and finishing it up on a strong note.
Exactly. Yeah. To start that strong note off today, we already concluded a Web Development Bell Day yesterday, but for today, to conclude MIT App Inventor, here's our agenda. Just gonna do a quick little minute, talk about the survey, which Joe was talking about earlier, make sure we're all sorted with that. Then our final riddle of the day for all of our Tuesday programs, and then finishing off the project, which we've been working on throughout the summer, the Spike game app through MIT App Inventor. So firstly, the survey, which I believe you guys have access to.
All right, so this is the final survey, right, Rayon?
Yep.
The final end of the session survey, if you guys would go ahead and put that in, or I'll put it in the chat one more time. Here it is. Let's give everyone like 5 minutes.
So just list us, guys, so we can get some information about what you guys are taking away from this summer. Some basic questions, fill out as much as you can. Give everybody 5 minutes to fill that out, and then we'll reconvene.
Give us some sort of reaction once you're done. Thumbs up or any of those 5 reactions. All right, we got one from Avnish.
As you guys are making your way onto the survey, pay attention, or actually very close attention, to the final question, which is the most important question. Who officially won the quote and meme wars? I don't know why there's a third option, but I guess Chase did jump in. Joe did jump in a couple times there too. So this is gonna be...
That's exactly who it's for. The other is for Chase. I knew he was going to put some sort of comment. So I don't know why he's not here today.
So Chase, if you're watching, be sure to fill us out too. We'll link this in the YouTube video for today as well. But this is the result we're going to share. Hopefully we'll have this by the end of the day today, or tomorrow we'll share who you guys think won. So
we're going to give some people a little bit of time to fill that out and put it up on the Google Classroom. But we will definitely announce like tomorrow who's in the lead and what and anything else we'll keep it up to date on the Google Classroom. So we'll make the official announcement like in a week on the Google Classroom. But yeah, for now, we'll check back tomorrow.
All right.
All right, so if anybody's having problems, do let us know, but just be sure to fill that out whenever you get a chance. Briefly fill out your responses so we have an idea of hopefully some cool things you guys have taken away from us throughout this summer.
All right, and now.
What do you guys mean by like memes? Like the memes that you guys put in the beginning or in between?
Yes,
the meme wars from the beginning.
So we
started off as quote wars, and then it became memes.
So are you? I'm not sure. Yeah, if you were part of the quote, but at the beginning of the summer, me and Lobby had like a meme picture, and then you guys would vote who won. Manish always was like Lobby's team, and never really got to want to win him over. But so just talking about that, just a fun question. Alrighty.
All right, now for the riddle of the day. I'm just gonna read it out loud, and you guys, let's give you guys 2 minutes, 1 minute to 2 minutes to answer it. There are 15 chocolates in a basket. Supposedly, you have 15 friends who each desire a chocolate. You give each of your friend 1 chocolate. After a few minutes, each of your friends has 1 chocolate each. Yet there is a chocolate remaining in the basket. How?
I know.
All right.
The last chocolate is yours.
There's a grammar problem. You aren't supposed to use "an" in front of a word that is that's a consonant. You're supposed to use it like you're supposed to have "an" as in an apple. You can't have it as in chocolate.
All right, here you go. There is no "and," there is an "a."
Can I have the link to the questions and all? I got in late, so I didn't get it.
Oh yeah, the survey?
Yeah.
Yeah, I will put that in.
So Chase, you joined the perfect.
I just finished the survey.
Great, thank you, Tejas.
Oh, wait, is that Chase?
Chase just joined. Yeah, Chase, we were just talking about you.
Wait, is that Chase? I thought that was Carolyn.
Oh wait, no, that sounded like Chase. Oh my gosh, no, never mind.
Oh wait, hold on. I need to change it. My mom must have
Chase.
used this.
That's 100% Chase.
Oh, okay, yeah, okay. It sounded like Chase. I was like, wait.
There we go.
Ah, there you go. Okay.
Chase, I'm sure that you'll find the final question very nice, but fill that out when you get a chance. In the meantime, anybody have any more thoughts?
If not, if you have an answer, go ahead and shout it out. We had one. Your friend is a basket. I wish that was true. No. So there are 15 friends. You're not part of the 15 friends. And there are 15.
Because one of the friends is imaginary.
Not really. There are 15 real friends, 15 real chocolate bars in a basket. You give each of them.
Are they still living?
I'm sorry?
Are they still living?
Yeah, they're all living alive, very much.
Lavdy, can I try?
Yeah, go ahead.
So 15 friends, you gave a chocolate to 14 of them individually, but the last friend, he got a chocolate with the basket and everything inside the basket.
There you have it. Nice job.
Does that make sense, guys? Okay, allow you to explain it.
Yeah. So to explain it, there were 15 friends. There were 15 chocolate bars and 1 basket. 14 friends got just a chocolate bar, and the 15th friend got a chocolate bar inside the basket. So technically, the last chocolate bar or 1 chocolate bar is in the basket, but that friend has it. So 15 friends still have 15 chocolate bars. Was that cool?
So if you brought in a plate of cookies, Lobby brings in a plate of cookies for everybody. For the last person, you just give them the plate? No,
Riddle, yeah.
that never happens.
Well,
Who really gives a chocolate to their friends?
A good,
Like, if it's like a tiny piece, or is it like a bar?
like a bar.
Mario.
Oh wow.
I've got 15 chocolates and no friends. I am living my best life.
Well, now we know not to expect anything other than chocolate from Paradosh now.
Oh. All right.
Alrighty.
So yeah, that was the riddle for the day. Hope you guys liked it. Let's go on.
Alrighty, so that concludes our riddles for all of MIT App Inventor, and now shifting our focus back to our project, which we will be concluding off with today. So quick recap of what we accomplished last week with our Spike game. Remember, it is a Spike game project which we are making in our MIT App Inventor. Over the past couple of weeks, we have already set up the whole user interface. Last week, we added a bunch of blocks of code to our app as well, which we connected to the user interface elements like the buttons, connecting all of that to our code. Lobby did explain that she's going to be posting a link to the code. So if you have any questions, you want to copy and paste, get caught up, that is totally possible by the end of today as well. And yeah, today we're going to continue to make some progress, and let's see how.
Yep. In fact, today's progress, our goal is to try to finish the app, and to do that, we have made some modifications in how we do code it. Initially, when we did start MIT App Inventor, all of us were coding together. We waited for everyone to catch up for dragging and dropping the blocks. But now that we actually want to finish the app, and this project is not just a small one, it's a pretty big game. Now what we're doing is I have the blocks made because dragging and dropping blocks is way harder than typing code, as I hope you agree with me. But I have the code built with the blocks. What we're going to do is we're going to drag the blocks in place, the huge blocks, and we're going to understand what each block does and how it plays a role in actually building the game.
Alrighty, so without any further ado, let's go on towards our MIT App Inventor website, and let's get started.
All right. Okay. Everyone see my screen? Yeah.
Yeah.
So, last time, or like 3 weeks ago, or in fact 5 weeks ago, because of that 2-week time period, we initialized global variables, all this stuff, and then last week we added these initialized blocks of code, basically, but they weren't just variables. They were basically setting those variables into what we want them to be, like initialize screen 1, and then when play sprite is touched, we want to do something, and then how to set up a game. We made several functions and then called them, and yeah, that's pretty much it. So today, what we have in store, actually, in fact, before I do start, since there are a couple of people that weren't here last time, I'll just go through like the designer and the blocks and how they are connected. So the designer is what the screen that we see. Over here in components, you'll see that we have a bunch of components from canvas. That's the canvas where the game will be played. And inside the canvas, there are a bunch of sprites. Sprites are basically things inside a game, like the bird, spikes, some sort of button, and all that. So those are sprites in a game canvas. Other than that, we have a score label and clocks, and those will be used to make the bird flap continuously, as well as make the bird go up and down and all of that. We also have a database to save the score, and that's a really cool thing that we did work on last time in calling the score from the database from the previous play. So that was really cool. And then finally, we have the sounds. Now the media over here, we did download like 5 weeks ago, or 5 to 6 weeks ago. And that was pretty simple. And then we added in all of the properties for the components. Now, last week and the week before last week, we started adding code and connecting that code with the designer. We initialized variables we added initialized functions and all of that stuff. And we used blocks from here in the left, from the built-in blocks. Those are the default blocks. And then the specific blocks for each component, like screen one and all of the labels, the sprites, the canvas, basically all of the components that we added in the designer. Today, we're gonna go through more of that code that we need, and I'm gonna explain to you what each of this code does. If you guys have any questions, do feel free to just shout out or put it in the chat, and I'll try my best to answer all of them. All right, so let's get started. I'm gonna start by like just color coding all this. Over here on the right, we have purple blocks all the way down. And purple blocks, if you see over on the left, are procedures. Procedures meaning like functions that we can use. Remember in JavaScript, we use functions to call them. Like yesterday, we used the function splitNum to call it, and then added in parameters, all that cool stuff. So that is what procedures is. Over here, we made the functions, and over here is where we will call them. Now, these are all, the outside blocks over here are all yellow blocks, because if you guys read that, the first one is when move clock.timer, and then when bird sprite collide with. So all of these are events. So control, and these blocks are taken from each component itself. So for example, when move clock.timer, that block is taken from here. If I click on move clock, wait a couple seconds for it to open up. All right. Looks like my computer is okay. There we go. Let's give it a couple of seconds. In this case, it did open up flap clock instead of move clock. Apparently, this screen is stuck. No, it's okay. I will refresh. Let's see.
You have a lot of blocks.
Yeah. Okay, there we go. Okay, we got 2 blocks, and that should do it. No. Okay. All right. Give it a couple seconds. I believe it's my Wi-Fi. Okay, cool. All right, back to the yellow blocks. When we move clock, let's try to open it up one more time. Hopefully it does open up. If it does not, then we'll wait a couple of minutes to talk about something else and then come back to the move clock. But yeah, so what I was saying is inside this move clock, there's gonna be a bunch of blocks related to just move clock, and that is where we got this block. Inside that, so when move clock.timer, I mean, I'm just showing you guys each function or each block, but through that, I'm also trying to show you guys how to get that, where to get that, and what it does. And also some functionalities of the platform, MIT App Inventor itself, because learning something is a whole process, and yeah. So if you click on this question mark, it will actually tell you what this block does. Now this block is saying move clock controls how long the bird can fly up when the player taps the screen. When the move clock is fired, we stop flying up and set is falling to true. So that is basically what this whole block does. That's really cool about MIT App Inventor. So yeah, that is the first block. Now the second one is when bird sprite collide with other. So other means anything. Okay, so if over here, if that get other, the parameter is equal to spikes up, so the spikes that are on the top, then call endgame state. Else if call is dead, else if then call endgame state. So if if the call is already dead, if the sprite is already dead, then we just call endgame state. If not, we also call endgame state because it just collided with something. All right, that is it. Now this is when it collides with something, but if we don't want it to collide with something, that means when it just touches the edge, that's when we want it to bounce back, right? And that is when we say, when bird sprite dot edge reached, do this. Call the score sound play. So there's going to be a sound that will play, like a bounce sound, like a turning sound. And then call setup placements. That will basically turn back the bird sprite. Finally, get global score to add 1 to it. So every time our bird sprite does collide with, or does bounce back from a wall and not collide with a spike, we add 1 to our global score. And then we're gonna set the label of the score label to that new global score. So that will update on the screen as well. All right, so that's the third block. Finally, this Y clock measures the, it helps the bird sprite move in the Y direction, so up and down. So over here, it says if global is falling. Now, global is falling is a global variable that we can manipulate anytime. And this whole function, or this control function, when Y clock is timer, so when Y clock is on, when the timer is running, there is one conditional that we go through. If global is falling, so if the bird is supposed to be falling, then we're gonna set the Y of the bird sprite to be 1 plus or 5 plus the original Y. And remember, in coding in canvases, plus is down. So if you add something to Y, it will go down instead of going up. You guys will see that in some JavaScript code that you use in the future, supposedly in high school and in canvases. Ooh, we got some drawing by Rayon. Okay. Rayon, would you like me to explain what that is?
Oh, on mute. Hold up. I was on mute the whole time. Okay. Yeah. Go ahead, Bobby. Yeah.
No, you can go ahead. I thought you were just drawing. Go ahead.
Let's talk. Okay. Yeah. So, like I was talking about, that's the important thing to notice, that when we're dealing with any canvas regarding coding, we're always talking about the 0, 0 point, like I do half right there. The 0, 0 coordinate is not in the bottom left, but actually the top left. So this top left corner is 0, 0 instead of a traditional X and Y grid, where at this point, you want to annotate, Lavdi? I can't for some.
Yeah.
Yeah.
Okay. So this point,
Yeah.
0, 0. That is. I'm horrible at annotating. Sorry about that. Okay. Yeah. So this point, as Rayan said, the top left corner is 0, 0. This is the X coordinate. X. There we go. Beautiful X. And this over here is the Y coordinate. Y. So if we add to Y, so Y plus plus, that's one notation in coding, then Y will go down. So this is, this over here would be like 0, 3. Okay, and then over here would be 0, -3. That's just the way in coding how grids work, and that is what this code uses. So I'm gonna clear all of the drawings, X out my annotation. All right, okay, back to the code. So yeah, that is it for the Y clock timer. Remember, Y clock is for determining the position, the Y position, so up and down of the bird sprite where it is. And basically, when the bird is falling, we want to add 5. But when the bird isn't falling, so when the user touches the screen to give it a push up, then we subtract 5 to make the bird sprite go up. So that is Y clock. Now, continuous flap clock, pretty simple. That's just making the bird flap its wings. It's just calling a function that's going to change the image of the bird continuously. And that is basically it. That's how sprites work as well. So yeah, After that is when flap clock.timer do this. So flap clock will also call this this change image, but over here we're gonna set flap clock.timer to false. We're gonna start and stop, start and stop. So both of these are just for the flapping of the bird, not the actual game, just a little bit of an animation. All right, over here, this actually is my favorite block of code because this is the main one that actually makes the whole game work. So when game canvas is touched, so in the parameters, there are 3 parameters, as you can see, the X, Y, and touched any sprite. X is the X coordinate of where the screen was touched. Y is the Y coordinate of where the screen was touched. Now inside that.
How do your videos off?
All right. Can you see me now? Yeah. Okay, cool. So if the global state is global state.ready, so when the game is ready to be played, then we will start the bird, we will make the bird fly. What this says is when we do click the play button in the beginning, the bird will stay there. And the bird will only start flying once we tap once after clicking the play button. And this is that code. So if the global state is ready, then do all of this. Else, if the global state is just state game, then we are going to call jump bird. So what jump bird is, basically it's gonna make the bird jump or add a boost to it. Think of the Flappy Bird game and how when we click, the bird goes up. That's the jump. That's what the jump bird function will do. And all the functions are on the right side. So except for these 2, because I couldn't fit them on the long list. So now that the yellow or the when functions are done, let's go to the purple blocks where these are the blocks that we have made, or the functions that we have made. This I'm gonna do the last because we'll need to know the others for that. But over here, so is dead is a function, and the result is do and then result. Do set global temp to false if it's dead. So this function is basically declaring the bird dead. Now, what else are we supposed to do? So we set global temp to false, and then there's a huge conditional that is, if the global heading left. So if we're going left, then then the speed is set to 0.1 and set global temp to true. Else, if we're going right, then speed is 0.1 and global temp is set to true. So this is a conditional for seeing if it's not dead. If it is dead, then we go to false. I hope that makes sense. And the result is what we use in JavaScript. It's the return statement. So get global temp. This function, as I said, determines whether our bird is dead or alive. So that is that. Only about 7-ish more functions to go, but we are there. So change image, as we saw in right over here, in the continuous flap clock and the flap clock. Change image is a simple function that literally just changes the image of the bird sprite. So what it does is, if the sprite is heading left, then it's going to use one set of image. Else, if the bird over here, else if the bird is heading right, or the other way, right, then we are going to use 3 sets of image that are different. Now, this is a huge thing for games. This is how sprites work. There's something in the chat. Oh, okay. So this is how sprites work. Sprites are a bunch of images that change really fast. So you think that it's an animation, but it's like 5 to 10 images that change like every second, or every 2 seconds, 3 seconds. And that is what is happening in here with our bird. Now we're gonna test this, this app later on, and we'll see how that works and how the bird does flap its wings. All right, so that is the change image. Then there's the setup bird position, and then setup placements. This is going to be just a setup thing for the spikes and the bird. The spikes, remember, we created a huge list over here, and we did this I think 2 weeks ago, 2 or 3 weeks ago, the first time that we did start coding our blocks. We made this list of a bunch of random places where we can put in our spikes. And this function right here, setup placements, is where we will use that list. So get list item, and then get temp, child index 1, 2, 3, 4. This is what how we're going to use that huge list of places. And we're just going to use random places to make the spikes look very randomized. So that's that. Again, what this conditional is it's a parallel of what we've been seeing before. For example, over here, if global heading left, then do something. Again, it's the same thing. If get global is on left, so if we're on the left, then we turn back, global is on left, and then we turn back, global heading left. So we kind of reverse everything, and we set bird sprite heading to 0, and changed the image of the bird sprite, set the spike 1x to new places, and yeah. And then do the opposite if we're not heading on the left. That is that. And then finally, this kind of goes on with our start game, play the game, and then finally end game state. First, we do call the death sound.play. There's a special sound for death in this game. You guys will hear that soon. I think it's pretty deadly. You guys can share what you guys think. But other than that, when the game is ended, when the bird does die because of the spikes, then the death sound plays, and then there is a retry button that is put on the screen. Now, all this code after is everything that happens on the backside of the game, everything that resets. So if get global score is greater than global best score, then we set the best score in the database to the global score. So we update the best score if our current score is the bestest so far. Excuse my grammar. Other than that, we set some things to visible. We set some timers to, actually we stop some timers because the game has ended. If we don't stop those timers, like move clock, Y clock, then the bird will continue moving. We don't want that to happen. When the game has ended, everything stops. And this is what that does. Again, this last part, this last conditional is putting the score. So score this, best this. If the global best score is greater than 0, we do put this. Else we just put the score. We don't put a best. And then finally, there's the jump bird. Now, just to remind you guys, where we did use this jump bird was when we called when game canvas is touched. So when we touch on the screen, what happens? Well, we want to make the bird jump or accelerate upwards. What does happen when we do click? So first we call flap sound.play. There's a sound for that. It's pretty satisfying when you do play. Notice how when coding, there's all these sounds, all these different components that we think aren't necessary, like sounds for death, sounds for hitting the edge, and then sounds for hitting the spikes. Keeping that separate, and then there's a sound for flapping. But when we do play it, you guys will see how all of that it plays a role in the overall game. So when the user clicks or taps on the canvas, then we play a sound, set global falling to false. So now the bird isn't falling, it's actually going upwards. We call change image because when you do want the bird to go up, changing the image would look nicer. That's just one way to animate it. And then move clock, timer enabled is set to true. And then flap clock, timer enabled is set to true. That is it. Now, let's see if I missed anything. So that was a lot of talking on my end, a lot of blocks to understand. But to kind of summarize everything, these are the yellow blocks. So when something happens, when some timer starts, or when the user clicks on the screen, when the bird sprite collides with the spike, or when a bird sprite bounces off the edge, what to do. And then all of the purple blocks are what we made. For example, set a bird position, change image, and then end game state, if is dead, all of that stuff. That looks about right. All of this stuff we did do last time, so no need to go over that because we don't want to do redo things. But let's go ahead and connect. After connecting, after showing you guys how that all works, I'm going to show how you guys can see this this project in the gallery. All right, so I'm gonna connect now. Sadly, only I will be able to connect to this this app using the QR code because you need to be connected to the same Wi-Fi. But you guys will definitely be able to do that once this this game is on the gallery, and you guys can download that on your own MIT App Inventor dashboard and then open that up and run that. I'm gonna click AI Companion. Open up my phone, open up my companion code, and then I'm gonna try to show it. Let me open up, here, let's see if I can pin my screen. All right, no, you guys can't see that. Let me remove my virtual background. All right. Of that. Okay. So we have this game right over here, play button, pretty cool. And we start playing. No. Okay, we start playing. Huh. That's weird. Let me scan that QR code again. All right. Okay. Let's see. No, okay. Let's see if I did connect the correct project. I'm gonna scan the QR code one more time and let's see if that works. Yeah, it probably was the wrong project. Okay. All right, one more time, guys. What I'm gonna do is connect AI Companion, scan the QR code, and it's loading. 47%. Okay, there we go. All my spikes, best score 3 because I have played this game before. Play that, and there is our bird over here. We got our score at the bottom with the label, and we have our bottom spikes already there because that was part of the setup, the game setup. Now, when we do click on the bird, actually there are also spikes on the side and the top, if you guys can see. Hope that is visible. And oops. Oh man, okay. As you guys know, I'm not very good at video games. And trying to play them up like the wrong side is even harder, but I'm gonna try. So if I do click on that, okay, I got a score of 1. My best score is 3, and it just collided with a spike. Now, my goal is not to win or try to do good on this game, but to show you guys that this game that we just made for the past 3 weeks and we finished today does work. Now, to finally show you how to get this game, let me share my screen. I'm gonna stop my pin, actually, remove pin, all right. Share my screen. So what you're gonna do is go to, where is it? All right, I'm gonna go to my projects, go to login to gallery, and this is basically a gallery for where you can search any project that anyone has published to the gallery. So if I search up, actually, let me publish, for example, week 3 images. Remember when we did images in week 3? I'm gonna publish this to gallery. Credit nah. Submit. Okay. Okay, we need an image file. I'll try to find one really quick. All right. Got that. Open. Submit. Okay, cool. Now, our name was, what was it? Images week 3. So, images week 3, I believe. No, cool. No problem. It was week 3 images. Week 3 images. If we do search that, all right, no. I think it does take some time. There we go. Okay, I just clicked on your apps for now, just to sort it up because my, this was like way down below. But there it is. This is online, like anyone can look at this. And if you do log into your gallery account, by the way, I showed you guys, if you go to projects, my projects, log into gallery, that's how you go to gallery. It will ask you for an email and your name, that's about it. After that, you can go into your gallery. If I click load app into MIT App Inventor, this will make a copy of that app, and you can now change it for however you want. So that is that. I'll just name it Tech Bytes Oh My Spikes and put that in the gallery, publish that in the gallery, and post that in Google Classroom. So look out for some name on Google Classroom. That is what the name of the project will be in the gallery. Cool.
Alrighty, well, that brings us to an end of our game. And it's something which you might notice more and more often. Like you can make some amazing games, but testing games out, it becomes a pain as the project becomes bigger and bigger. So we saw sort of on display, and it's something which you guys will start to experience more as the time comes along. But speaking of time, guys, our time with MIT App Inventor today is coming to an end. Our summer programs are coming to an end with the last one being tomorrow, our web product development, where we will be wrapping up our adventure game as well. And today we have successfully concluded MIT App Inventor with our Spike project game. This MIT App Inventor, it was a new experience which me and Lobby started off with, something which we hadn't really experimented before the summer months, but over the summer, as you guys can see, Lobby led the way with creating this app, and hopefully you guys took in some information about how many cool things which we can create with coding. We saw in the spring programs with Python products, which we can make with JavaScript over the summer, how we can make websites and web projects, to now seeing how we can implement the same idea and concepts to apps, which we can play and test out on our phones, which is pretty cool. So, like this slide says, this is our second to last goodbye from me and Lobby here and Joe at the Tech Bytes team. We hope to get you guys tomorrow when we are concluding Tech Bytes for the summer. But other than that, guys, you guys are free to go, and we will catch you guys tomorrow. See you guys.
Thanks, guys, and thanks for filling out the survey. Please, if you haven't